Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Today I'm going to talk a little bit about the data science popularization that we've seen in the last few years and the need for data management education as part of data science education in both formal educational programs and in workforce development programs. I should mention I work at CEASN, the Center for International Earth Science Information Network at Columbia University, and there we operate the NASA Socioeconomic Data and Applications Center, which focuses on human interactions in the environment. So we have seen education about workforce development increasing recently. Or education about data science, and we've also seen the popularity increasing about data science in the last few years, and this is really great, but I think we also need to have scientific data management as part of this education so that we can continue to have access to the data over time and to facilitate long-term stewardship of that data. So what I'm recommending is that we do include scientific data management as part of these education and workforce development programs. So recently we see, as we can see from these headlines here, from Forbes and the Economic Times, data science is really being recognized. And what these headlines are saying to us is that there is not enough of a workforce out there to meet the new increasing demand for data scientists. We've got to get more people educated to take on the roles of data scientists, and there's going to be this increasing demand, and we're already seeing this demand. And the new demand we're seeing isn't necessarily mentioning data science or data scientists directly. They're giving them various terms, but we are seeing the increase. For example, sometimes they refer to and looking for people in informatics or looking for people to do data analysis. And in terms of the skills that they're actually looking for, they're saying that they range from computer science to mathematics to art. One article is saying we're looking for people who can be entrepreneurs with data, to discover new ways of analyzing data and to mine data to come up with new theories and new processes. We're also seeing that there are now programs in data science, and they don't all necessarily have the name data science. Sometimes it's business systems analytics, or they're calling them informatics. So they're going under a variety of terms, but they're at not only the undergraduate level, where we're seeing what they're doing at George Mason University, but we're seeing graduate programs such as the one planned by the University of Dundee, and then Syracuse University, where Jean Kin is, they've got the Certificate of Advanced Study in Data Science. So these show how these programs are stepping up to meet the needs for data scientists to meet this demand. We can also look at the journals that are out there. And so I've arranged 3 of the journals on data science here, going from what I would consider the most broad-based journal to the more precise ones. The Codated Data Science Journal is, I would consider, very broad-based, and I should tell you I'm a member of the editorial board, And we have with us today the editor-in-chief, Professor Shuichi Iwata. I guess I should put in a plug here. Certainly, we would welcome any submissions that you have for the journal, for articles. The scope of the Codated Data Science Journal, as I said, is very broad. When we say data, we're looking at all aspects of the processing and curation and preservation, et cetera, and analysis of databases or new types of databases and various ways to process the data, or the complexity of the scalability of the data, as well as ways to distribute the data. So as I say, that data science, Codated Data Science Journal is very broad. And it's also looking at models, applications, and interfaces, et cetera. The APJ Data Science Journal, that's not quite as broad, but it's still not very narrow. They're looking at ways of mining data or extracting information from data or generating new theories or empirical laws from the use of data. And then the Journal of Data Science, that's more precise to analysis of the data or modeling the data in applications or using applied statistics or other quantitative methods to analyze the data. So we see, just looking at the journals, there are a variety of issues in data science. It's really not one discipline per se, and it's really cross-disciplinary and benefiting from the knowledge of various disciplines that are out there. What I'm suggesting is that we start to think about including data management as well as, say, just statistics or analysis or visualization, some of the more popular and current topics in data science. Such issues that I'm talking about might be like data management planning, where we look at how we're going to plan for the management of our data and begin managing the data. Some data policy issues where we think about how the data are going to be used and what we would do with the data, how we would facilitate access to the data and facilitate use of the data so that, in fact, the data do get used. As Carol was just mentioning, the data gain value as they are used. So this is great for everybody, the data producers, the data providers, and the data users. And then lastly, looking at stewardship and preservation issues. So when I'm talking about data management planning topics, we see, for instance, NSF is requiring data management plans of the organizations that submit proposals for funding. If you haven't planned how you're going to manage your data, let's face it, the data really won't be managed from an organized or planned perspective. Really, if we're going to engage in any kind of work, we want to plan what we're doing. And data management is no different. Looking at archives, if you're going to be managing your data, unless you're going to manage it yourself, you might want to look at a particular archive where you might want to deposit your data, and that archive may or may not distribute it. If you're going to look at a particular archive, you might want to look in terms of their commitment as an organization to your data. Are they serving your community, for example? How is the archive being managed? And is it sustainable over time? Are they going to fold up shop next year or in 5 years, or are they in it for the long haul? Do they have a track record of managing data over time? And then likewise, looking at the system that's, of the archive and how it's managed and the expertise that's there, the skills of the people that are there. The data project itself has to be planned. How are the data going to be collected? Who's going to be involved in the team? Are all the people involved going to be authors, for example? And then curation issues. How will the data be prepared for distribution? And then who's going to be distributing them and how would they be distributed? Would they be distributed through just data products or through some kinds of data services? In terms of data policy topics, an example of some of these topics might be looking at intellectual property rights or issues such as privacy. We certainly want to protect the privacy and the confidentiality of data or individuals or property that might be captured within the data. Likewise, there might be other restrictions that have to be imposed on the data for various reasons. And then there's also the issue of security. Will we be providing the necessary security for the data? One, so that the data do not get changed by mistake and will be available over time, but also if there are some restrictions on the data or some confidentiality issues, we might want to include those in our security plans. Looking at data accessibility and use, there are various issues which we could be teaching. How to describe and document the data. Let's face it, if the data aren't accurately described and documented, people won't be able to find them in the first place, and then they won't really be able to use them. Having adequate documentation for the data is really critical, and having worked in a data center for some time, let me say that you can't really have enough documentation out there. There are always more opportunities to further document your data. Standards. Those who are involved in data science should be aware of different content standards out there as well as the metadata standards. These can be very helpful for enabling the use of the data as well as for discovery as well. How to make the data interoperable and how to integrate the data with other data is also a concern. If we facilitate the integration of our data with other data sets, then that's going to facilitate additional use of the data. Likewise, choices for how we disseminate the data. The timing of the dissemination is always an issue, and the provenance of the data are very important, and those who are in data science really need to understand these issues. If we don't collect the information about how we've created the data, then those who are using the data later won't really know, and as those who are creating the data go on and work on other projects, they won't be available necessarily to answer their questions. So having this captured and documented as part of the data is very important. Likewise, we need to be able to make sure that the data are available over time and that people can get to them and locate them over time through persistent identification. So this is also a critical issue for accessibility. Open access. Well, if the data aren't freely available for use, who's going to be able to use them? Only those who can afford them. So open access is a critical issue, as well as ensuring that the data are cited by those who use it. So certainly we want to encourage the users of our data to cite the data so that others will know how they came upon the results and be able to make comparative analyses using the same data. And assessing data use and impact. If we've created a data set, we've invested our time and effort into that, as well as the time and effort of others, it's great to be able to see whether the data have been used and the impact those data are having. And our funders also want to know certainly where their resources have gone and whether they've had any effect at all. And then examples of data stewardship topics is how we might prepare the data to be archived and how we might prepare those for submission and how we would go about submitting them to an archive so the archive could acquire those data. Often archives have a data appraisal process where they've got different procedures and different criteria that they're looking at to determine whether the data should be disseminated from that particular archive and to their communities and how they might best do that. So preparing the data for the data appraisal and working with an archive to appraise the data would help not only the archive to make decisions about that, but help them to facilitate access to the data over time. Another issue in software or data stewardship is software dependencies. If the data can't be accessed 5 years from now because the software or the operating system is no longer available, that is a real problem. So software dependencies are a concern, and to be aware of those issues, individuals can then address those concerns in terms of looking at perhaps creating the data, migrating them to other formats, or looking at paths for later migration. The integrity, validation, and verification of data are also critical. If people are getting your data, they want to make sure that these data are the data they think they are. And if somebody has conducted a study using the data last year and someone wants to replicate that study and they're getting the data this year, they want to make sure they're using the same exact data set. As I mentioned, data migration is critical if we've got software dependencies or the technology's evolved and we can no longer access the data from its format. And looking at levels of service, the data can be accessed using a variety of ways or integrated with other data in services, which might make the data more usable by a variety of audiences. And so understanding of the possibilities for data services and working with an archive to allow the data to be accessed by a greater population would certainly facilitate more use in the long run. And then finally, making sure that the data are available over time certainly helps to make sure that future users can use the data. So, as I said before, data science is a very broad area and it's cross-disciplinary. And sure, it's easy to say, let's also teach data management in there, but how are we going to do that? There are lots of other topics that are being taught too. And the students are interested in learning as much as they can, but there's only so much time. So we have to look at how we might be able to either squeeze the data management topics in there or to integrate the data management topics as part of other issues that are being taught. Also, if there is an interest in data management, we really need to sell the data management at some point, show that there is a need for this education, and that there are benefits from learning about data management. Let's face it, data management really isn't as glitzy as other issues such as visualization, where you see all the eye candy that's created from the data. People say, oh, I want to do that. When you're talking about long-term preservation of data, well, it's not quite as glamorous. And then another challenge is that we need the expertise there. It's drawing on various disciplines, so we need to get the right experts to be teaching these issues so that, in fact, they can be included in either the curriculum or the different training programs that are being developed. So, as an example, if we were going to teach intellectual property rights, we would certainly want to show the practical applications of that. That is, they're important for acquisition. If the data are being acquired by an archive, they need to have the rights in order to make those data available, and they need to have the rights in order to perhaps modify the data and to store the data. The users need rights too. And if there are any qualifiers or restrictions on the use of those data, they should be specified up front, and those who are creating the data or managing the data should be aware of it. Data integration is critical, and so rights for creating derivative products and for using those products is necessary. Likewise, distribution rights or third-party distribution rights are critical. And then rights for a long-term use. So if the rights are expiring after some period of time, then obviously people wouldn't be able to use those over time. In terms of teaching how rights might be assigned, it would be important to show the students about the public domain. That's an opportunity where the data would not have a copyright, and so anybody could use those data, and they wouldn't have any restrictions on their use. The Creative Commons CC0 license is a common way to do that, and often we see government agencies, when they create data, they result in the public domain. The Creative Commons also has other licenses. The CC BY license is the least restrictive, where it's only requiring that those who use the data cite the source. And they become more restrictive, such as those where no derivatives are allowed or no commercial use are allowed, or requiring that the data are used, when they're used, they're shared and using the same license. And if you have software that you've developed or scripts associated with the data, you can make those openly accessible using the Apache license. So these are examples that the students would certainly gain from being aware of. Making the data openly accessible, as I said, is going to enable more use, and not only the publications, but the data as well should be open access. Likewise, the software should be open source, and whether it's just the code, you might want to include the scripts, etc., and adopting open standards so that, again, if others are adopting the same open standards or they're openly available to others, people can make crosswalks and therefore facilitate greater use. And so how do we do this? Well, we can introduce data science within other, or introduce the data science using the data management topic. So rather than showing people right away that they can do all these statistical analyses and make eye candy using visualization techniques, we could describe about the archival process and dissemination so that others can use them. Ethics is important in any educational forum, and certainly if we're talking about educational or ethical uses, we might want to mention data management as well. And then if there are some statistical modules in our educational program, we can talk about the analysis of archival processing or citations, and that's a good way to introduce data management topics. So here's an example of teaching data management in a data science program that's an ICPSR summer program, and you see they've got confidential data management issues and documentation, et cetera. So these are critical for data management. I was glad to see this program out there. And then finally, I'd like to just say that there are benefits from this. We can facilitate greater discovery of the data, accessibility, enable further use of the data and reuse, and allow the data to be integrated with other data or interoperable with other data, and facilitate long-term use of the data as well. Thank you.